നിന്ന് PDE ഫോം ചെയ്യാനുള്ള കുറച്ച് എക്സാമ്പിൾസ് കാണാം. ഫസ്റ്റ് വൺ, x മൈനസ് എ ദ ഹോൾ സ്ക്വയർ പ്ലസ് y മൈനസ് ബി ദ ഹോൾ സ്ക്വയർ പ്ലസ് z സ്ക്വയർ ഈക്വൽ ടു 1 ആണ് സർഫസ് തന്നിരിക്കുന്നത്. അതിനകത്ത് 2 ആർബിട്രറി കോൺസ്റ്റൻസ് എയും ബിയും ഉണ്ട്. അത് രണ്ട് എലിമിനേറ്റ് ചെയ്താൽ മതി, നമുക്ക് PDE കിട്ടും. സോ എലിമിനേറ്റ് ചെയ്യാനായിട്ട് ഡിഫറൻഷ്യേറ്റ് വിത്ത് റെസ്പെക്ട് ടു എക്സ് ചെയ്തു, അതിനുശേഷം ഡിഫറൻഷ്യേറ്റ് വിത്ത് റെസ്പെക്ട് ടു വൈ ചെയ്യുന്നു, അതിനുശേഷം നമ്മൾ സബ്സ്റ്റിറ്റ്യൂഷൻ ചെയ്യുന്നു. നോക്കാം ഇവിടെ ഡിഫറൻഷ്യേറ്റ് വിത്ത് റെസ്പെക്ട് ടു എക്സ്, ദിസ് ഫംഗ്ഷൻ ഡിഫറൻഷ്യേറ്റ് വിത്ത് റെസ്പെക്ട് ടു എക്സ്. അപ്പോൾ 2 ഇൻ എക്സ് മൈനസ് എ ദ ഹോൾ സ്ക്വയർ ഡിഫറൻഷ്യേറ്റ് വിത്ത് റെസ്പെക്ട് ടു എക്സ് ചെയ്യുമ്പോൾ 2 ഇൻറ്റു എക്സ് മൈനസ് എ പ്ലസ് ഇത് ഇൻഡിപെൻഡൻറ്റ് ഓഫ് എക്സ് ആണ്, സോ ഇതിന് ഡെറിവേറ്റീവ് 0 പ്ലസ് ഇസഡ് സ്ക്വയർ ഡിപെൻഡൻറ്റ് ഓഫ് എക്സ് ആണ്, സോ 2z ഇൻറ്റു ഡോ ഇസഡ് ബൈ ഡോ എക്സ്, അതായത് പി ഈക്വൽ ടു 0. അതായത് അതിൽ നിന്ന് എക്സ് മൈനസ് എ പ്ലസ് ഇസഡ് പി ഈക്വൽ ടു 0. സോ നമ്മളിവിടെ എഴുതിയിട്ടുണ്ട് എക്സ് മൈനസ് എ ഈക്വൽ ടു മൈനസ് ഇസഡ് പി എന്ന് ഇതിൽ നിന്ന് സോൾവ് ചെയ്തെടുത്തു. അതേപോലെ ഡിഫറൻഷ്യേറ്റിംഗ് വിത്ത് റെസ്പെക്ട് ടു വൈ വി ഗെറ്റ്, ഇത് ഇൻഡിപെൻഡൻറ്റ് ഓഫ് വൈ ആണ്, സോ 0 ആയിപ്പോയി. ഇത് ഡിപെൻഡൻറ്റ് ഓഫ് വൈ ആണ്, ഇത് 2 ഇൻറ്റു വൈ മൈനസ് ബി എന്ന് വന്നു. ഇതിനെ 2z ഇൻറ്റു ക്യൂ, അതായത് ഡോ ഇസഡ് ബൈ ഡോ വൈ ആണ് ക്യൂ ഈക്വൽ ടു 0. ദാറ്റ് ഈസ് y മൈനസ് ബി പ്ലസ് ഇസഡ് ക്യൂ ഈക്വൽ ടു 0. സോ ദാറ്റ് y മൈനസ് ബി ഈക്വൽ ടു മൈനസ് ഇസഡ് ക്യൂ. സോ നമുക്ക് ഇത് എക്സ് മൈനസ് എയ്ക്കും y മൈനസ് എ ബിയെയും നമുക്ക് പിയുടെയും ക്യൂവിൻ്റെയും ടേംസിൽ കിട്ടിയിട്ടുണ്ട്. അതിന് നമ്മളിവിടെ ഇക്വേഷൻ 1 സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്തു. സോ നമുക്ക് എന്ത് കിട്ടും? മൈനസ് ഇസഡ് ബി ദ ഹോൾ സ്ക്വയർ പ്ലസ് മൈനസ് ഇസഡ് ക്യൂ ദ ഹോൾ സ്ക്വയർ പ്ലസ് ഇസഡ് സ്ക്വയർ ഈക്വൽ ടു 1. സോ ഇസഡ് സ്ക്വയർ ഇൻറ്റു പി സ്ക്വയർ പ്ലസ് ക്യൂ സ്ക്വയർ പ്ലസ് 1 ഈക്വൽ ടു 1. That is the required PDE. And the next example, z equal to x plus ax square y square plus b. Differentiating partially with respect to x, we get dou z by dou x, that is p equal to 1 plus 2axy square. And differentiating with respect to y, we get dou z by dou y, that is q equal to, it is independent of y, so it is equal to 0. And this become 2ax square y, 2ax square y, and b is constant, that will become 0. And so p and q are, we get p and q, and we have to solve this to eliminate a from these equations. So just multiply this equation, second equation by y and the first equation by p x, we get qy equal to 2ax square y square and px equal to x plus 2ax square y square. So that we get px minus qy equal to x, that is p minus 1 into x equal to qy, and that is the required PDE. Now the third example, z equal to ax plus by. Differentiating with respect to x, we get p equal to a, and differentiating with respect to y, we get q equal to b. So instead of a and b, we can substitute p and q. Therefore z equal to px plus qy, and the required PDE. Now some example exercises are given to you have to try it to solve down. I will read once. Question: eliminate the parameters a and b from each of the following equations and find the corresponding PDE. First one, z equal to x plus a into y plus b. Second one, 2z equal to ax plus y the whole square plus b. Third one, z square into 1 plus a cube equal to 8 into x plus ax plus b the whole cube. Next we are going to obtain an equation for obtain a PDE for a special type of surfaces. Formation of PDE from surface of the form f of uv equal to 0, where u and v are known functions of x, y and z. Here see, f is a function of u and v, and the u and v are again some functions of x, y and z. In such a situation, how we can form the PDE? That is, we are going to see. Generally, we will find a PDE, and for further For problems, we just substitute the values. Consider the surface S of the following type. F of uv equal to 0, equation number 1, where u and v are known functions of x, y and z, where z is again a dependent variable of, and x and y are independent variable, as we see. To eliminate the arbitrary function f, we have to differentiate one partially with respect to x and y respectively. That is, here we have f is the surface with the two variables u and v, and u and v are again functions of x, y and z. So we have to eliminate the function f. F is the arbitrary function here. U and v are known functions. We have to eliminate f, so that we have to differentiate the equation 1 by with respect to x and with respect to y. On differentiating f of uv equal to 0 with respect to x, first one is doing with respect to x. We have to differentiate f of uv. F of uv equal to 0 with respect to x and with respect to y. First doing with respect to x, that is, f is a function of u and v. So we have to apply the chain rule. That is dou f by dou u, then dou u by dou x. U is a function of x, y and z. So dou f by dou u into dou u by dou x plus dou u by dou y. The term is 0 because we are doing with respect to x, plus dou u by dou z into dou z by dou x. This u is dependent, is a function of x, y and z, and z is a function of x and y. That is why we have done like this. Dou f by dou u into dou u by dou x plus dou u by dou z into dou z by dou x, plus dou f by dou v into dou v by dou x plus dou v by dou z into dou z by dou x, which is equal to 0. This is the differentiating with respect to x. That is, we can replace dou z by dou x by p. Now again differentiating with respect to y, we get dou f by dou u into dou u by dou y plus dou u by dou z into dou z by dou y, that is q, plus dou f by dou v into dou v by dou y plus dou v by dou z into dou z by dou y, that is q, equal to 0. Now we get two equations, equation 1 and equation 2. From this we can solve for dou f by dou u divided by dou f by dou v. And from these two equations we get two equations 3 and 4 by solving for dou f by dou u by dou f by dou v. Now we have to equate these two equations 3 and 4. That is, we get dou v by dou x plus dou v by dou zp divided by dou u by dou x plus dou u by dou zp equal to dou v by dou y plus dou v by dou zq divided by dou u by dou y plus dou u by dou zq. Now on cross multiplication we get we replacing dou v by dou x by vx. For simple notation, we replace dou v by dou x by vx, dou v by dou z by vz, dou u by dou y by uy, and dou u by dou z by uz, and so on. Thus we get, on cross multiplication, we get vx plus vzp into uy plus uzq, equal to vy plus vzq into ux plus uzp. Now expanding, we get like this. From this, these two terms are same, and we can here p is missing, sorry, here is a p. Now expanding, we get vx ui plus vx uzq plus vz uyp plus vz uzpq equal to ux vy plus ux vzq plus uz vyp plus uz vzpq. Grouping for coefficients of p and grouping the coefficients of q and constant terms, constant, sorry, not a constant, in other terms, we get p into vz uy minus uz vy plus q into vx uz minus ux vz equal to ux vy minus vx uy. This can be written as dou uv by dou yz, because dou uv by dou xy means determinant of ux uy vx vy, that is ux vy minus vx uy. Similarly for other terms also. So these three terms can be rewritten as dou uv by dou yz and dou uv by dou zx, and it is dou uv by dou xy. Okay, because dou uv by dou xy is given as determinant of ux uy vx vy, that is ux vy minus vx uy. Okay, so we have obtained a PDE of the form p into dou uv by dou yz plus q into dou uv by dou zx equal to dou uv by dou xy. Okay, this is linear in p and q, and degree of p is 1 and degree of q is 1. That is, it is linear in p and q. So this is the PDE corresponding to the surface f of uv equal to 0. Now we can see some exercises by that you have to solve by this method. Okay, eliminate the arbitrary function f from each of the following equations and find the corresponding PDE. First one, f of z minus xy comma x square plus y square equal to 0. See, this is of the form f of uv equal to 0, where u equal to z minus xy and v equal to x square plus y square. Then we have the PDE from the equation 2 as p into dou uv by dou yz plus q into dou uv by dou zx plus dou zx equal to dou uv by dou xy. Now we just find these coefficients. So we have u equal to z minus xy, v equal to x square plus y square. So is ux uy uz vx vy vz. We have to find first find ux uy uz and vx vy vz, and then we can find the coefficients dou uv by dou yz separately, and substituting we get the PDE. That's a method. So ux is here minus y, uy is minus x, uz is 1. Note here, when we are finding ux uy uz, z is, if there is no term of z, v is here. See, here is no terms of z, so vz equal to 0, and vx equal to 2x and vy equal to 2y, and vz equal to 0. And substituting in the equations, we get dou uv by dou yz equal to, it is easy to remember. See, the coefficients of p is dou z by dou x, that is it is differentiating the coefficient dou z by dou x with respect to x. So the coefficient term does not contain the term of x, that is dou uv by x, y, z. See, x, y, z. Dou z by dou x is p. So this coefficient is dou uv by y, dou yz. Okay, then plus q. Q means dou z by dou y. So that term does not contain the term y. So and this can be remembered by dou uv by dou zx as a continuous circular path. As z y is not there, so then other is z, then x, and this one is dou uv by dou xy. Okay, and dou uv by dou yz is equal to uy, see, uy uz, vy vz, uy uz, vy vz, and the determinant. So the determinant can be found, and this we get, it is minus 2y, and these 3. Similarly, we can find dou uv by dou zx equal to 2x, and dou uv by dou xy equal to 2 into x square minus y square. Substituting in this equation, we get the PDE as minus 2yp plus 2xq equal to 2 into x square minus y square. That is x cube minus yp equal to x square minus y square. See the next example. F of xy comma x plus y minus z equal to 0. Here u is xy and v is x plus y minus z. U and v are functions of x, y and z. So in the PD is of the form, we have this form. So just find ux, uy, uz, vx, vy, vz as ux is y, uy is x, uz is 0, and vx is 1, vy is 1, and vz is minus 1. So finding the determinants, we get dou uv by dou yz equal to minus x, dou uv by dou zx equal to y, and dou uv by xy is equal to y minus x. Then substituting in this equation, we get the PDE. That is minus xp plus yp equal to y minus x. That is yq minus xp equal to y minus x. That is the required PDE. Similarly, you have an exercise to find the PDE corresponding to the surfaces f of x plus y comma x minus root z equal to 0. And second one, f of xyz comma x plus y plus z equal to 0, and this one f of xy by z comma x minus y by z equal to 0, and f of x plus y comma x minus root z equal to 0. See, you have to solve these problems as you have to solve these problems in your note.